5.3. Adding or subtracting unlike fractions. Unlike fractions are fractions with different denominators. Okay. And in order to add unlike fractions, you need to know how to find the LCD, which is also the LCM, okay, between the denominators in your fractions. Okay, so part A, again, negative 4 over 15, negative, negative, positive, 7 over 25. And see here, we need to find the LCD, okay, of between 15 and 25. So you can either use the cake method or calculate it in your brain, whichever works for you. Okay, so here, so 5 times 3 times 5 is 75. So 75 is your LCD. As you can see, it's the same way as calculating your LCM. So 15 times 5 times 5 in the numerator, and so negative 4 times 5 is negative 20. 7 times, here we go, we have 3. Okay, 3. Okay, so that's positive 21. So that I get 1 over 75 as my answer. Okay, and I'm going to do the next one. Here, I know that between 8 and 14, my LCD is 56. And if you don't believe me, let's do a cake. 2, 4, 2, 7. Okay, and then that's it. And 2 times 4 times 7 is 56. Okay, and then we need to multiply by 7 here, times 7, and get 35. And 14 times 4 times 4, so we get 44. And our final answer will be negative 9 over 56. Okay. And let me do the next problem. Alright. The LCD between 7 and 21 is obviously 21. And we have a negative 6. So 7 times 3 is 21. So I need to multiply by 3 in the numerator. Okay, and negative 6 times 3 is negative 18. And we have a negative 16 here. We don't need to do anything to the negative 16 because the denominator is already 21. Okay, negative 18 plus negative 16 is negative 34 over 21. And you can rewrite this improper fraction as negative 1 and 13 over 21. Okay? And let me erase this because I might need the space later. And here we have adding or subtracting mixed numbers. And I'm going to work this out for you. Here we have 5 1/4. I would like to change that to an improper fraction. So that would become 21 over 4, and then 7 over 5. And 4 and 5, they share an LCD of 20. And so I'm going to have to multiply 4 by 5 and the numerator of 21 by 5. And this will give me 105 times 4 here. And 7 times 4 will give me 28. And here I'll get 133 over 20. I'm going to change that to back to mixed number, so I would get 6 and 13 over 20. Okay, and that's my answer. And let's do the next problem. And here we have two ways of doing this. I can first change this around. Okay, so I see that all I have to do is change this to 8, so times 2, which is 6 over 8. So 10 minus 3, I get 7. 7 minus 6, I get 1 over 8. Okay, and if you would like to use another way, just to change all your mixed numbers to improper fractions to be safe, you may do that also. So 3 times 4 is 12. 12 plus 3 is negative 15 over 4. And then 87 over, 87 over 8. And I know that my LCD is 8. So I can do this. Over 8. Negative 15 times 2 is negative 30. Plus 87. 87 minus 30. I get 57 over 8. And then I can do 7 and 1/8, which is the same answer. Okay? You can choose whatever way you like to do the problem. And for the next problem, I'm going to solve it vertically, so some of you may like it this way better. Okay? Okay. -4, -9. And I see that between 15 and 10, they share an LCD of 30. Okay, so times 2, get 30. So I do the same thing to the numerator. Alright, times 3, get 21. And then I have two negative signs, so -4, -9, get -13. 21, 14, that's 35 over 30. And as you can see, 35 over 30 is improper, and we need to change that. You should get -14 and 5 over 30 as your next step, and you need to simplify. So your final answer should be -14 and 1/6. Okay? Yes, these could get quite complicated, so try to find the best way to avoid careless mistakes. And now we're going to move on to simplifying an expression. And you just have to be careful with those variables, alright? And the same thing between 6 and 9. The LCD is 18. So I'm going to draw a fraction bar and write 18. And times 3, I get 18. So I need to do a times 3 to D2. Okay, so 3D times 2 times 2, I get 4D. And 3D plus 4D, I get 7D over 18. Alright? And here, I would like to rewrite my fractions as rational numbers. Okay, I know that between 5 and 7, my LCD is 35. So 5 times 7 to get 35, I need to do that to the numerator as well. And times 5 here, times 5, I get plus 5y here. And -7y plus 5y, I get -2y over 35. Okay, and this is a y here. Yep. Okay, and then that's my answer. Okay, this is a fraction bar. I'm going to move on to the next problem. Here, I have 3 fractions. That's annoying. Okay. But that's okay. Okay, let's work this out. Between 8, 9, and 18, the LCD is 72. You can use the cake method to find out. So 8, 9, 18. Okay, remember this is chapter 4. Okay, and here 8 times 9 is 72. So I need to do the same thing in the numerator. 3x 9 is 27x. 9 times 8 is 72, so times 8, 8x plus 8x. And here we have 18 times, let's see, 18 times 4. And that's also 72, so I need to do the same thing to the numerator. So negative 5x times 4 is negative 20x. Okay, and then after we add 27x plus 8x minus 20x, we should get 15x over 72. And after you do some simplifying, you should get 15 divided by 3 is 5, and 72 divided by 3 is 24. So your final answer should be 5x over 24. Okay? Okay, part D, evaluate the expression. Okay, so I can sub in x for 2 and 9 over 25, and y I can sub it in for negative 3 and 1 over 20, and z I can sub it in for negative 4 and 3 over 10. And here I can rewrite this as an improper fraction, negative plus negative 61 over 20. And here I can rewrite this as negative 43 over 10. And I see that between 25, 20, and 10, the LCD is 100. So for the next step, I'm going to set it equal to fraction bar over 100. Okay, so 25 times 4 gives me 100, so I need to do the same thing to the numerator. 59 times 4 is positive 236. 20 times 5 here, and then I get negative 305. And 10 times 10 times 10, I get a negative 430. And now I am going to add the numerators up. So I'm going to first add negative 305. Okay. 5, 3, negative 735. So negative 100, 735. Okay, I'm going to have to do some subtraction here. Get 9, and then 12. Subtract 3 is 9, and then 4. Get negative 499 over 100. And if I were to rewrite this as a mixed number, I can do negative 4 and 99 over 100. Yeah, that's a crazy answer, but it's right. Okay, and let's do the next crazy problem. Let me erase this so I get some workspace. Alright, x minus y minus z. I would pay special attention to these two problems because you might be given such complicated problems like these. So x is 2 and 9 over 25. And you see this negative sign here? I'm going to recopy it. And y is negative 3 and 1 over 20. So I need to write it like this. Okay, I'm going to have to write a negative sign again. Okay, I'm going to use red. Okay, and the next one, I have to recopy this negative subtraction sign and then use the negative color. I mean a red color, not a negative color. Negative 4 and 3 over 10ths. Again, I'm gonna change all of this to improper fractions so it's easier to work with. Okay, remember negative, negative, positive. Okay, and here 61 over 20, negative, negative, positive, and I can get 43 over 10. Again, they still share the same denominator as the previous problem, right? Okay, so here's still 59 plus 305 plus 430. And after you add the numerator up, you should get 971 over 100. So your final answer should be 9 and 71 over 100. Okay? Okay, horses. Of the 3 different types of horses on a ranch, 1/4 are Arabians, 2/5 are Thoroughbreds, and the rest are Morgans. What fraction of the horses are Morgans? Okay, so our goal is to find out the fraction of horses that are Morgans. Okay, so I'm just going to write Morgans here. So my equation should be 1/4 plus 2/5 plus x equal to 1, because 1 is the whole. Okay, so I'm going to add 1/4 and 2/5 first. Okay, so they share a LCD of 20 times 5 times 5, so this would be 5, and times 4 plus 8 plus x equals to 1. 13 over 20 plus x equal to 1. And let's solve for x by subtracting 13 over 20 to both sides. Okay. Cancel, cancel. X, bring this down. Okay, 1, I can rewrite it as 20 over 20, which is still equal to 1, okay? So the reason why I chose 20 is because I have a denominator of 20 here. Okay, so 20 minus 13 is 7 over 20, and this is your answer. Okay, and that's it.